All right, so this challenge problem, wait for the muted sign to go away. This challenge problem, I think is kind of actually a little bit fun, um, and not just because, I don't know, maybe it's just because I am a math teacher. A hot air balloon begins rising from the ground at 4 meters per second. Okay, so I'm going to draw a little picture. Okay, I have a hot air balloon, and it's just now leaving the ground. It's basically still on the ground. And I never pretended to be able to draw. So there's my hot air balloon. I don't think that's too bad. Okay, there's my hot air balloon. And here's my person in the hot air balloon. And very excited. Okay, so my hot air balloon is starting to rise, and it's rising at 4 meters per second. So it's going this way at 4 meters per second. At the same time, we have a parachutist. And so we had this guy who was falling, and his parachute opens. That's way too big. Okay, so we have our parachutist. His parachute's open now. I would draw a parachute. It's kind of like that. That works, right? Looks like a parachute. Okay, so there's our parachutist, and I don't know why, not a skydiver, he's a parachutist. And he is going, so at the time that the balloon starts to leave, he is at a height of 200 meters. And he's going down at a rate of 6 meters per second. Okay, so what are the two equations, or what are we trying to figure out with this? Well, this is fine. So this picture is fine. What we want to figure out, I think, you could figure out a lot of things. You could figure out how long is it going to take the parachutist to get to the ground, how long is it going to take the balloon to get up to 200 meters, or when are they going to be at the same height? Okay, but either way, what we're going to do is we're going to write out two equations, and with these two equations, what we're going to do is we're going to make them based off of height. So for our balloon, our height is equal to, let's start with our y-intercept. Where does the balloon start? The balloon starts on the ground, so at 0, so we're not worried about that. And it rises at 4 meters per second. So we're just going to call it t for time, and it's in seconds. So the balloon goes up at 4t, t is in seconds. Our parachute person, our skydiver, whatever he is, our height, well, he starts at 200 meters, so that's our y-intercept. That's where he starts. After 0 seconds, he's at 200 meters. And then he's going down, so he's losing 6 meters per second. So 6t plus 200. Those are going to be our two equations. H equals 4t, and h equals negative 6t plus 200. Okay, that's our two equations. Now, what does the solution mean? Well, first of all, let's solve it. We already have this we already know that h, right? H is the same thing. So let's put 4t in for h and solve our equation. So we have 4t equals negative 6t plus 200. That's a 6, not a g. Okay. And let's solve for t. We want to get rid of the negative 6t on this side, so let's add 6t to both sides. That gives us 10t is equal to negative 6t, positive 6t cancel out, 200. Divide both sides by 10. And t is equal to 200 divided by 10. Same thing as just 20 divided by 1, so 20. So 20 seconds. T equals 20 seconds. Okay, after 20 seconds, what does H equal? Well, if we plug that in for our red equation, H equals 4 times 20, which is 80, and that's in meters. And what does that mean? Well, what that means is when our balloon floats up 20 seconds and our parachutist floats down 20 seconds, they'll both be at, I drew my hot air balloon way too big. They'll both be at 80 meters. Okay, that's when they'll both be at the same height. That's what that solution means, is they'll both be at the same height. After that, the parachutist will be lower and the balloon will be higher, assuming they continue to rise and fall at constant rates. Okay? If you like drawing pictures, even if you don't like drawing pictures, it's kind of fun to draw pictures for a math problem, even if you're not any good at drawing. See? Okay, that's it for that one.